So back in Algebra 1 and in Algebra 2, we solved two variable linear systems. And we used lots of different ways to do that. One of those ways was elimination. So if you're doing elimination, you're going to combine by adding or subtracting the two equations together to eliminate, like the name says, a variable. For example, I have this system, and if I add the two equations together, 3x plus 5x is 8x, 2y plus negative 2y cancels out, 4 plus 12 is 16, divide by 8, x equals 2, and once you know what x is, you can plug it back into either equation. So 3 times x, which is 2, plus 2y equals 4, so 6 plus 2y equals 4, minus the 6 over, so 2y equals negative 2, divide by 2, and y equals negative 1. So your solution is the ordered pair 2, negative 1. And that solution is the place where they would intersect on a graph. Furthermore, we can even go as far as checking our answer. One of the beautiful things about math is you can check it. And so when I check, I'm just going to plug my ordered pair in back to both the original equations. 3 times 2 plus 2 times negative 1 has to equal 4. Well, this is 6 minus 2, which equals 4. The first equation checks out. And then on the second equation, 5 times 2 minus 2 times negative 1 is supposed to equal 12. This is 10 plus 2, which equals 12. So it checks out and our answer works. So on number 2, we're going to do elimination again, except for this one has a little bit of prep work. If I add or subtract my variables right now, the coefficients in front of my variables don't match on either x nor y, so I can't just go ahead and add them together. So I'm going to multiply my second equation by a 4. So I'm going to keep the top equation, 2x minus 4y equals negative 7. And the bottom equation, I multiply everything by a 4. So you get 20x plus 4y equals negative 4. And now I can go ahead and combine these. The y's are going to cancel off. I get 22x equals negative 11. Oh, positive 22. And so I'm going to get that x equals negative 1/2. And then I can plug that into either equation. I'm going to use the top one because half of 2 is 1, which is nice and easy. So 2 times negative 1/2 minus 4y equals negative 7. Negative 1 minus 4y equals negative 7. I'm going to add the 1 over. I'm going to get negative 4y equals negative 6. Divide by negative 4. And y equals positive 3/2 because 6 over 4 reduces to 3/2. So my answer, my ordered pair, my solution set is negative 1/2, comma, 3 over 2. So I'm going to go ahead and have you pause the video, and I'm going to have you solve it, and then come back because I'm going to remind you how to do substitution as well. So you should have gotten the ordered pair for 3 as your answer, but we could also have done this problem with substitution. So I was going to do substitution. I'm going to take the bottom equation. I'm going to solve for y. So 5x minus y equals 17. I'm going to add the y over and subtract the 17 the other way. So 5x minus 17 equals y. And then I'm going to substitute that into the other equation. So my other equation said 2x plus 3 times stuff equals 17. And that stuff I'm going to plug in as y. Y equals 5x minus 17. And so when I do this, I get 2x plus 15x minus 17 equals 17. So I get 17x equals, add the 17 over, 34. Oops, nope. Sorry, I didn't distribute right here. Let me fix that. So I get minus 30, 51 equals 17. Sorry, I forgot to distribute to both terms. So then I get 17x, because I've added the two x's together, minus 51 equals 17. I'm going to add this over and get 17x equals 68. Then x is going to equal 4, which is the same thing I got before. And then I can take this x and plug it in up here. 5 times 4 minus 17 is going to equal y. 20 minus 17 is 3. Same ordered pair, 4, 3. Okay, so this problem is also elimination, but we're going to have to multiply both equations by different coefficients, different constant values, so we can get something to eliminate. And I eliminated y in every problem, so just for funsies, let's do the x this time. So multiply the top equation by a negative 2, the whole thing. That's going to yield negative 10x minus 6y equals negative 18. I'm going to multiply the bottom equation by a 5. So now I get a 10x minus 20y equals 70. And now I can add these two equations together. The x's will cancel out. You'll get negative 26y equals 52. Divide both sides by the negative 26 and y equals negative 2. Then you can plug that back into either equation to find your x. So I'll do the bottom one. I get 2x minus 4, the y value is negative 2, equals 14. 2x plus 8 equals 14. 2x equals 6. I move the 8 over by subtracting. X equals 3. So my answer, my solution set, my intersection point of the two lines is 3, negative 2. And then it says that I need to verify by graphing. So insert a graph. So here's my graph, and to graph these, I need to put them in slope-intercept form. That would be the most helpful. I could plug points in and get 2 points and draw the line, but out of good practice, we'll do some algebra. So the top equation I did in red earlier, so I'll continue in red. 5x plus 3y equals 9. I get 3y equals negative 5x plus 9. I just moved the 5x over, and then divide by 3. So y equals negative 5 over 3x plus 3. You have to divide them both by the 3, so 9 divided by 3 is 3. So that thing has a y-intercept of 3. And then you go down 5, 1, 2, 3, 4, 5, and over 1, 2, 3. Down 1, 2, 3, 4, 5, over 1, 2, 3. Make sure that you have a negative slope. And then we're going to draw a line and connect the dots. Not the world's best draw, but we'll do our best. So there's that line. The other one I did in blue earlier, so my blue equation, 2x minus 4y equals 14. Negative 4y equals negative 2x plus 14, because I moved the 2x over, then I divide everything by a negative 4. So y equals a negative 2 over negative 4 is going to make a positive half. X minus 14 over 4 is going to reduce by 2s to 7 over 2s. So negative 3.5. So negative 3.5 right there. This one has a positive slope, so it goes up 1 and over 2, up 1 and over 2. And you can see these two are going to intersect right there, right here, at that magic dot, which is what we found algebraically, which was 3, negative 2. So it doesn't matter how you solve the system, because no matter how you solve it, graphing, substitution, elimination, you should always get the exact same answer. So now we have this doozy of a problem to deal with, and it looks really horrible, all the decimals. So we could multiply everything. Both equations, I'll do top in red, by 100. And that will just move the decimals over and make us have nice whole numbers. So just because you have decimals doesn't mean you can't multiply both equations by something, make the decimals go away, make your life a little bit easier. Makes my top equation become 2x minus 5y equals negative 38. That 100 in essence moves the decimal place over twice on everything. The bottom equation, I'm going to multiply by 100. I'm going to get 3x plus 4y equals 104. And now that it is much nicer, I'm going to multiply again just so that I can do elimination or substitution or anything of that nature. Let's do elimination. Let's multiply the top equation by a negative 3. It's going to get me to negative 6x plus 15y equals 144. Oops, sorry, not 144. 114. The bottom equation I'm going to multiply by a 2. 6x plus 8y equals 208. Now I'm going to add these two equations together because my x's will eliminate and cancel each other out. 23y equals 2, carry the 1, 2, 322. Divide both sides by 23 and you'll get y equals 14. Go back to either equation and solve. I'm going to use the red equation just because the numbers are a little bit smaller. So I'm going to get 2x minus 5 times 14 equals negative 38. 2x minus 70 equals negative 38. I'm going to add the 70 over. And I'm going to get that 2x equals 32. Divide by 2 and x equals 16. So my solution set or my ordered pair is y 16 was x and y was 14. So I think the math has been pretty straightforward this section, but I need you to know these vocab words. So if you have exactly one solution, it's called independent and consistent. So consistent means I have a solution, and independent means that I can move one line or the other line or both lines, but no matter what, they're going to move independent of the other one. One does not impact the other. So this is two lines that intersect at a point. They're what's called skew lines because they're not parallel, they're not perpendicular. They are skew. They intersect at one point. They even could be perpendicular. That would still intersect at a point, but they're not parallel. Infinitely many solutions means that they are exactly the same. So that they're exactly the same, they're going to touch. So they're still consistent, but because they have to be exactly the same, aka on top of each other, if you move one, you have to move the other, making them dependent upon one another. This last one, no solution. Since I don't have any solutions, it's just called inconsistent. And so this is what happens when you have two parallel lines. They never, ever, ever intersect. So please make sure you know these vocab words. So now that we have the vocab words in our head, let's give us a mathematical, concrete definition of what matches them. So I'm going to solve this system. I'll multiply the top equation by a 2. So I'm going to get 12x minus 10y equals 6. I'm going to copy this over. Negative 12x plus 10y equals 5. I'm going to add these two together. So this cancels off, this cancels off. So I have nothing left on the other side. So 0 equals 11. Well, 0 never equals 11. That doesn't ever happen. And so this is no solutions. The lines were the same. Sorry, the lines were not the same. They're not skew. They're actually, in fact, going to be parallel lines, and they're never, ever, ever going to intersect because this is a false statement. 0 never equals 11, and so that's a false statement, which led me to my no solutions, which we're going to call inconsistent. Let's try this problem. I can multiply the top equation by a negative 2.
That's going to get me negative 4x plus 2y equals negative 2. The bottom one we'll leave alone. And when you add these together, the x's cancel off, the y cancels off. You're left with a 0 on this side. And on this side, the 2 and negative 2 cancel off, so you're also left with a 0. Well, this is a true statement. 0 equals 0, or 7 equals 7. It's a true statement. That means they're always equal to each other. So we can say the system of equations is consistent. They have at least a solution. Consistent means they have a solution. In fact, there are infinitely many solutions. Because they're always touching. And not only is it consistent, but this one is dependent. Because if I move one line, I have to move the other, so they are consistently always touching. So this is an application problem. It's about equilibrium points. Equilibrium points are where, especially in economics, where a system is going to be balanced out. So, for example, supply and demand. Where does the supply and the demand of a product equal each other? What is the magic number that keeps the system balanced, where the demand is not higher than supply or vice versa? So, since both of these equations equal P, I'm going to set these two equations equal to each other. And now that the equations should equal each other, the p's are already gone, so I'm going to solve for the x value. I'm going to move all the numbers over to one side, and I'm going to add the decimal to the other side. And I'm going to divide. So 3 million x, the number of units I need, is the number I need to produce. Now, what price should I sell them at to cause me to be able to produce this and have this equilibrium point? Well, let's plug that back in and find out. I'm going to use the top equation just because it's a 1 to multiply by. So you end up with P equals 180 minus 30. P equals 150. That's the magic price. So my equilibrium point is to produce 3 million units of whatever it is, and I want to sell them at a price of $150 each.